Welcome back. So let's discuss this prop placement manager script that adds all the props to our rooms. Now again, we have this dungeon data reference. Next we have the serialized field list of the prop. This is the scriptable object that I have shown you in the previous video, and we have only one list for all the rooms. Of course, you could extend this to have separate rooms, have separate list of props, but this is a simple example. Now next we have this corner prop placement chance. This is a float value from 0 to 1, and basically this tells us if every corner in our room will have a prop or not. This is just for the sake of making our generation more organic looking. So we have 70% chance that we are going to place a prop in a corner. Next we have a serialized field private game object prop prefab. This is the prefab, so I will show it to you in a bit. This is just a game object with a sprite renderer so that we can place a correct sprite and place it correctly in our tile or in our map. This is just a game object with a sprite renderer, and we are going to place it so that it matches the layout of the tiles on our map. And we have again a Unity event on finish, and again this will allow us to add an extra step to our procedural generation algorithm. Next in the awake, of course, we are getting the dungeon data by finding this object. If we do not find it, we can as well return, because we need the data from it to process our room and to place the props. So first of all, we are going to again loop for each room in our dungeon data rooms. And here we need to decide kind of which placement goes first. So I have selected the corner props to go first because we only have 4 corners in our example, but you can manage this differently or shuffle this placement depending on which props has more constraint than the others and which should be placed first. So what I do here is create a list of props, so our scriptable objects corner props equals props to place, and I use this where extension method. This is from the system.link library, and this allows me to select all the props that have the corner bool flag set to be true. And this allows me to filter all the props for only the props that can be placed in the corners. And this is because I wanted to make those methods a bit more reusable. So I have the method called place corner props. I'm passing the room, so the room reference, so that we can save the positions and the references to the props in this room object, and I'm passing those corner props. So let me show you this method. In this method, we are going to first calculate the temp chance, or get the value temp chance equals corner prop placement chance. So this was our 0.7f. And we are going to loop for each vector to int corner tile in our room dot corner tiles. Again, we are going to get this value from our room object, so this list of corner tiles. And we are going to get Unity engine.random value. If this value, so random value, is less than corner prop placement chance, actually I wanted to use here the temp chance, because later on, if we, for example, don't place the prop in one corner, we want to increase the chance by 0.1 so that we place in other corners the props, because it would look pretty stupid if there were no props in the corners very often in our project. So in our generation, we want to increase the chance if we do not place a prop, but if the value is generated and it is less than the temp chance, we are going to generate the prop to place equals corner props. So those are the props from this list. We are going to randomly select one of those props, and we are going to then call place prop game object at, passing the room, the corner tile, so the tile that we are right now considering, and the prop to place, so the prop selected from our list. And we also take into account if it wants to be placed as a group, we place a group object, passing again the room, the corner tile, the prop to place, and we are passing the search offset. Let's first talk about the place prop game object add, because this is the method that we are going to use in other places. Now I did my best to comment this code. This method returns a game object and again takes the room, the placement position, so the origin, and the prop to place. And we instantiate the object, the game object prop equals instantiate the prop prefab, and we are going to assign the sprite render to the prop sprite renderer, and we are going to assign it to the prop, so this new game object get component in children sprite renderer. Let me show you this prefab. So here it is. Let me disable the gizmos. This is our prop, and our prop is just a parent object with a child object that is a separate game object containing a sprite render. This is because we may want to place, for example, a bigger prop in a specific position. So let's say that this is the position of a 𝗃, but if our prop, let me select something different, our wheel prop, here it is much bigger. So while the prop parent placement is good, we need to offset the child of this. So we are going to just move it, and we are going to place it right there. But the prop parent is placed on this specific 𝗃. And now, of course, we can add a collider to it, and this is 2 by 2, so we need to include this size in the definition of this prop. Okay, so this is what we are going to do here. We are going to instantiate this prop prefab, and we are going to access its child object. When we have this sprite render reference, we can set the sprite to be the prop to place our scriptable object prop sprite. And next we are going to add a collider, which will be the capsule collider. So all we need to do is add to the prop sprite render, so to the child object, a capsule collider 2D using this code here. Next we are going to set the collider offset to be vector 2.0, and we need to assign its size. If the prop size x is greater than the prop size y, so it is wider than taller, we are going to set the collider direction to be horizontal, and this is just because we are using the sprite capsule collider 2D. And next we are calculating the size of the collider equals vector 2 prop to place prop size x, and I'm going to not set the collider to fill in the whole sprite, but rather set it to be 80% of the size of the prop, so that we can move around this prop easily. So we use this x value and y value of the prop size. If you don't recall, this is just a specific collider size that we pass here as a property of our scriptable object, so the definition of the prop. And next we are going to set the collider.size equals the size. Next we are setting prop transform local position to be vector 2 placement position, so the vector 2 int the position of our 𝗃. And next what we are going to do is set the prop sprite render transform local position, so the sprite render position to be prop to place prop size times 0.5. So in our project it will look like this. We have this prop parent and we place it in the position of the 𝗃, which is the bottom left corner of a 𝗃. And now, since the prop has the size 2 by 2, we are going to move the prop sprite, so the child object of the prop parent, by 1 in the x and 1 in y. Then we get the correct position. So this is how we are going to place our props. I think I have made a mistake in explaining it previously, but that's exactly how our code will place those props. And next it will add the capsule collider to it. And again, since this toggles will tweak it differently based on this direction, we may want to set it to be horizontal, so now we will be able to set it like this to fit a wider prop. Okay, so this is the idea. And lastly, we want to add this to our room data. So room prop positions added a placement position, and a room prop object references, so the game object added a prop, and we are going to return the prop. We are saving this data because we may want to regenerate our dungeon, and for this to work we want to delete all the props that were placed previously, so we can grab them easily from this room prop object references. Now the second method that I think we had was this place group objects. So we have this if statement, if placed as a group, we were using this group object, place group object method. So this method takes in the room the origin point, so group origin point, prop to place, but it also has the search offset. So let me explain how it will work. The tricky part when placing those objects in the specific position is that we have, for example, this corner. And this corner, we know that this is this origin position, and we need to place a couple of those objects. Now, if we want to place those, we can get the offset from this position by 1, so we can find all the tiles around this position. So from this origin position, all the tiles that are within the 1 point from it. So we are going to find those like this. We are not using the distance, but we are using the for each loops that starts with the -1 and -1 and goes to up to +1 and +1. Okay, so this is the search offset. It gives us the offset for our 2 for loops to generate those positions where we can potentially place objects from our group. Now it can work poorly when placing bigger objects because it was designed to place small objects as groups. Okay, so with this in mind, we are going to calculate how many of those elements we want to create. So int count equals, we are going to create a random value from prop to place group min to group max. Since we have already placed 1 prop in the center, we are going to subtract 1 from it. And next we want to clump it. Since I'm using the search offset max is 8 fields, I think, around this origin point, I'm going to clump this. This count will be useful for a later part when we are checking how many props can we place. Now to find those available positions, we use 2 for loops. We are going to create a list of available spaces, and we set the x offset in the first loop to be minus search offset, so 2. So we are going to find the spaces 2 from our origin. This is how we create those squares. So this is x offset and y offset from minus search offset to be less or equal. This is important to the search offset in both of those for loops. And we are going to calculate the vector to int temp position based off our offset values from this group origin point, group origin position. And if the floor tiles contain this temp, and the dungeon data.path, so we cannot replace objects on our path, so this is why we are checking if the path does not contain the temp position, and if the prop position, so the props that were already placed, do not contain this position. If all of those conditions are true, then we have a space that is available for placement of our group prop. And this is how we find those props around our origin point. And lastly, we need to randomize those positions so that we can select those by random and we can make this look a bit more organic. So this is what we are doing here. We are ordering this list of available spaces using, again, the link library by the GUI ID, new GUI ID. This is the easiest way to shuffle our list by a random value based on the random value that we generate here. Now, at the end, we need to place those props as many as we can. So we are going to check int temp count equals count less than available spaces dot count. So if the count, so our 8 or less positions, is less than the available spaces dot count, then we want to return this count because this is a lower value. If this value is higher than the available spaces because of those conditions, we want to return the available spaces dot count. Because, for example, we only have 2, not 8. And in this case, we are going to look for each I equals 0 till I equals less than temp count, and we are going to reuse the same place prop game object add method that we have just discussed for placement of a single object in a corner. And it takes the room, the available spaces I, so the position that we have found to be free, and the prop to place. So the end result is that we can place those crates together. Now, for some reason, I only see 3 of those in a line, so there might be a bug in my code. I will check it because otherwise there is only a singular barrel here. So I'm going to check it and update the GitHub repository, but this is the idea behind what we want to create here. Okay. The next step is in our process room method, after placing the props in the corners, to place the props near the walls, since again we have only limited number of tiles near walls. So this is why I'm choosing to place props on the tiles near the walls first before I do the inner tiles. So here we have placed props, and the inner prop tiles will also use this, so I did my best to make it reusable. And again, we are going to create a list based on the bool flag from our prop scriptable object. So we create left wall props equals props to place where, and we select only those where the near wall left bool flag is set to be true. Then I want to order those by descending, so we are going to order them by the prop size x times size y. So we want to place the bigger props first before we place the smaller ones. Since again bigger props are harder to place, and we are going to convert it to a list, because now we are going to use place props, and let's take a look at how this method works. Okay, again there is some additional documentation here if you want to check it on GitHub. Now in this place prop method we are taking again the room reference, the prop list reference, the hash set near wall tiles. So I'm going to pass here which tiles are we going to use based on our what we want to do. So if we want to place near the left tiles, we can pass here the hash set representing the tiles near the left wall. So this is how we can make this method more reusable, by passing the specific tiles that we want to use as the placement positions. And we are going to pass here what is called placement origin corner placement. So let's take a look at this. This is an enum, and again where to start placing the props examples for the starting at the bottom left corner and searching if there are free spaces to the right and up in case of placing bigger props. And we have bottom left, bottom right, top left and top right. Just to explain it, the idea here is that if we want to place these bigger props, which takes 2 spaces, we may want to start to look for tiles from this top, this is top left tile. So let me maybe use a different color. Top left tile, this is the origin. And if we are placing 2 by 2, we may want to start from this and go to the right and to the bottom to search for spaces when we are placing this near this top wall that would be here. So back in the code, we can see that now we are going to create a hash set of temp positions. Now we need to remove path positions, so the positions that can't be blocked, from the tiles that we want to use for the placement. Now I have reused it for the near wall tiles, and then I have reused it for the inner tiles, so this should probably be, let me rename it, right click, rename. I'm going to call this, for example, available tiles. So those are all the tiles that are represented inside our room, and we want to remove from it the path tiles. So we create a new hash set of the available tiles. And next, all we need to do is call temp position except with, this is another method from the hash set collection type, and we are going to remove the tiles representing the path. So again, in our project, we have those data that we have created, and we are just excluding this path. For example, from this bottom, from this list of bottom tiles, we are excluding one of those tiles because this represents the path, and of course we do not want to place any props where there is our path. So this is the idea. Okay, so when we have those temp positions, we can look for each prop to place in our wall props, so this props that we have passed here, and we are placing all the props. We are trying to place all the props. That is why I have mentioned that you might want to have some more elaborate system of selecting which props to place. First thing, of course, we need to calculate the quantity of the props. We are using the random range method, and we are going to pass the prop to place, so the scriptable object placement quantity min and placement quantity max. Since this takes in range of minimum is inclusive but max is exclusive, I'm adding here +1 to include the max limit. And next we are using for loop for I equals 0, I less than quantity, and this is where the magic happens. We are going to call temp position except with the room prop positions, so the props that we have already placed, in case we have placed in a corner a group of objects that take in some of those positions that represent a wall, we want to remove those from our temp positions before we try placing anything there. Next, we are going to calculate a list vector to int available positions, and we simply need to again shuffle those temp positions. So order by x, such as GUI ID dot new GUI ID and we are going to shuffle this, and we are going to convert it to a list using our link library, and at the end we are calling try placing prop brute force. This method takes again the room, the prop to place, available positions, so this list that we have shuffled, and we are going to shuffle it before every placement, and then we are going to pass the placement type, so we want to start from the bottom left corner or the bottom right corner, whatever we think is the best way to place it. And if this returns false, we are going to break, because there are no more tiles to check, because this will try to place props brute force, so on all tiles that are available. Basically, what we are going to do is try placing the object starting from the corner specified by the placement parameter. So we are going to look for each eye till the available positions.count. This is why I'm calling it this brute force, and we are going to calculate the position vector to int position equals the available position on the index I. And next we need to check if room prop positions contains this position. We are going to continue. Now we are going to check if there is enough space around to fit the prop, because if we are trying to place a bigger prop, we need to do exactly that. So we are going to create a list of vector to int free positions around. We're going to use try to fit prop method. We are going to again place the prop to place available positions, the position that we have selected, and the placement type. So let me show you this method. And this method will simply create a list of vector to int free positions equals new. Next we are going to check if placement equals placement origin bottom left, we are going to do this code, else if this is bottom right, this code, else if this is top left, this code, and else we are going to have some other code. For example, for the most common bottom left placement, we are going to set the x offset equals 0 and y offset equals 0. And this is because, as I have already tried to explain, when we are placing this prop, we want to start from some specific corner. So this is the bottom left corner, and we want to check the tiles up and to the right. And those loops simply make sure that we check the correct positions. And in each of those double for loops, we are checking if vector to int temp position, again using very similar code that we used before. We are just adding to the origin position the new vector int offsets. If we are checking if available positions contain this temp position. In this case, we are adding this to the free positions list that we have created at the top. And if we have selected the correct case for our placement that we have passed as one of those arguments, we are going to return those free positions. Okay, so having this, all we need to do now is we need to check if we have enough spaces to place this prop. So now if the free positions around that were returned here, the count is equal to prop size x times prop size y, so basically the size of our prop. If this is the case, then we can start placing the prop game object at, and we have already discussed this method, and we are going to look for each vector to int position in free positions around. We need to lock all those positions, since there might be only one prop placed, but it might be taking 4 positions, so this might be a 2x2 wheel thingy that I have shown. So this is why we are blocking those in our room prop positions. We are adding all the free positions around this that we have found for the prop placement. And of course we need to deal with the groups, so we are checking if prop to place as a group. We are going to try place this as a group of objects, and we are going to return here true. So this is because we are going to look for each available position. If we did that, we are going to return false, because there is no point in trying to again place this prop. So in our code here we have this quantity, but if we have no other available positions, we want to break from this, and we want to try placing, for example, a smaller prop from our list. Okay, bear with me just a bit more. So now all we need to do is pass the right wall props, so we just select the props that can be placed near the wall right, and we passed our place props, so the main method, the room, the right wall props, so the list that we have calculated here, and the room dot near wall tiles right as the available tiles that we want to use, and of course the placement origin corner. And we repeat this for the up tiles and the down tiles, so the tiles near the up wall and the tiles near the down wall. Now as for the inner tiles, all we do in the code is reuse the same method, just calculating the inner props. We use place props and we just pass the placement origin corner as the bottom left. Since we want to place, for example, this bigger prop, we can start from the bottom left corner and we can start searching for the tiles around it to fit it into our inner tiles spaces. Okay, so the last step is to place enemies in our dungeon. So we are going to place the player as well as the enemies in the spaces inside our rooms, but we want to use the breadth first search algorithm to find all the spaces, all the tiles that are near the path. So we can end up with positions that are blocked by all the props, like this position here, which is unavailable to reach. Now of course we could reach it if the colliders are small enough, but basically if we place an enemy here, it will be blocked by all of those props. To avoid this, we are going to use the breadth first search algorithm to search all the tiles that are reachable from this path. Okay, I'll explain the code behind it in the next video. See you there!